So today what we want to talk about are properties of real numbers. And some of these properties you may be more familiar with than others. You're going to be responsible for knowing all of these properties and what they look like, and not only that, how they're used to solve expressions. So first of all, we have the commutative property for addition and multiplication. The definition of that is the order of the terms can change. So real quickly, as an example, I can have 1, that's a term, plus 2, that's another term, equals 2 plus 1. The order of those terms changed. And the reason why I use terms and not numbers is because we can also use variables in this. So let's use an example for multiplication. I can say A times B. Remember, we want to get away from that times sign that we're used to. So if you put in a little times symbol, make sure that you fix that and you put in the dot. A times B equals B times A. So that's showing an example of the commutative property for addition and multiplication. It's the same thing, the only difference is we're using add or multiply. That's the only thing that changes. We would not use this for subtraction. Okay, no subtraction. Let's put a note underneath that. No subtraction. Or division. It's only good for multiplication and addition. Associative property for addition and multiplication. That's our next property that we have here. And what that means is that the grouping changes. The order doesn't change, but the grouping changes. And what I mean by grouping, and I'm just going to put it in here, is a little parenthesis symbol. The grouping can change. Not the order of the numbers. Not the numbers, okay? So if I had, and this goes for both addition or multiplication. So here, if I have the parentheses, 1 plus 2 plus 3, that would equal 1. I can move my parentheses around. See, the order isn't changing at all. Plus 2 plus 3. Or if I had multiplication, remember the numbers, or I should erase numbers and say not the terms. If we want to stay consistent, terms. That's why we want to always do it in pencil. So when I mess up, you can erase what I mess up and fix it. So if we're doing multiplication, I can say C times D times E equals C times D times E. The only thing that moved around were the parentheses. Now, distributive property. Now, real quickly, going back to associative property, again, that's not for subtraction, not for division, okay? You can't use it for that. Distributive property. What I'm going to do is I'm going to show you an example of the distributive property, and then we'll talk about a definition for a distributive property. So if I have 1, I don't want to use the number 1, let's say 2 times the quantity A plus 3. what I want to do is I can pass that 2 or distribute that 2 or multiply that 2 to everything inside the parentheses. So it would be 2a, I draw my arrow from 2 to a and I get 2a, but I have to draw my arrow from 2 to the 3 as well. That plus sign just comes along, and then 2 times 3, I'll write that. I know you know 2 times 3 is 6, but I can write it like this as well. I could write 2a plus 6 or 2a plus 2 times 3. This also works, though, for subtraction. So I can say 2 times the quantity C minus 4. And I would multiply again. 2 times the C, that equals 2C. 2 times the 4. If you don't draw 2 arrows, then you're doing it wrong. Okay? If you're not multiplying that 2 to everything inside that parentheses, you've messed up. If you only multiply to the first thing in parentheses, you're not going to get it correct. So 2c, here I can bring my minus sign along. Okay? This does work for subtraction. And then 2 times 4. If you wrote 8, that's perfectly fine as well. So distributive property, as a definition, we could go ahead and say multiply a value to all terms in parentheses. And I apologize if I spelled that wrong. Additive and multiplicative identity properties. Okay. So, additive property. Now, additive and multiplicative properties of identity. What we want to remember is identity means that we're basically doing something to a number and it's going to remain the same number. So it's kind of like identical. So if I was to go ahead and say A times something is going to equal A. Okay? A times something is going to equal A. Or 4 plus something is going to equal 4. See how whatever is here maintains its identity over here. Whatever's here, that 4 maintains its identity and it's over here. So what do I have to multiply to A to equal A? And the only thing you can multiply to A to equal A is going to be the number 1. The only thing you can add to 4 to equal 4 is going to be 0. So based upon that, we can come up with a definition of, for multiplication, okay, let's start with additive. For addition, add 0 to any number. I'll change number to term. And for multiplication, it says multiplicative, but we can say multiplication. Multiply, for multiplicative, we want to multiply 1 to any term. And if you either add 0 or multiply 1, the number maintains its identity. You can, if you multiply 1 to A, it's still going to be A. It maintained its identity. If I would add 0 to 4, it's still going to maintain its identity and become and still remain 4. That's the big thing about the identity property. You want to maintain your identity. You don't want to change it. Even though you're doing something to the term, it's still maintaining its identity. And it's important to maintain your identity no matter what changes occur. Additive and multiplicative inverse properties. Additive and multiplicative inverse properties. Now, inverse is kind of like the opposite, okay? Inverse means that we're going to be changing it to its opposite. So, or doing something with it with an opposite. So I'm kind of gonna, I know I'm writing a little bit big here, but in case you're not with me, I'm gonna go ahead and just draw this line here so we're together. Okay, so again, when I'm multiplying, let's say A times something is going to equal 1. Now, isn't that strange? With the identity property, I multiplied by 1 and I still got A. Here I'm multiplying A by something and I'm going to get 1. See where there's a little bit difference? And this is probably the key thing to help you remember. Now, with the additive inverse, I'm just still going to use 4. And I'm going to say 4 plus something is going to equal 0. Do you see where here I said 4 plus 0 equals 4. Now I'm going to say 4 plus something equals 0. So that 1 and 0 still kind of comes in play with the inverse property, but it's now been moved to what it equals instead of what we're multiplying and adding it to. So if you were asked to compare and contrast the identity and the inverse properties, that might be something that you want to consider. Now, what we want to multiply A to, we don't want to multiply A to 2, but what we want to multiply A by is its inverse. It's multiplicative inverse, okay? So I just want to put a little side note over here underneath. If I have A over 1, I can multiply it by its reciprocal, okay? That's a key term that we need to remember, reciprocal. And its reciprocal is 1 over A. That's the reciprocal of A over 1. Okay, or it's its multiplicative inverse, okay? A equals A over 1. So if I multiply this, remember multiplying fractions, A times 1 is A, 1 times A is A, and A divided by A is going to equal 1. So if I say A times, I'm going to multiply A times 1 over A and get 1. Okay, now I want to add the inverse of 4. Inverse means opposite. So the opposite of positive 4, negative 4. And that's how I get 0. So for the additive inverse, you would add the opposite to equal 0. All right, that's what we want to equal 0 when we're adding the opposite to equal 0. For multiplication or multiplicative inverse, we want to multiply by the reciprocal to equal 1. Finally, the multiplicative property of 0. Okay, a lot of people get this and inverse properties mixed up. Okay, now the thing is, when we're doing the inverse property of addition, we're adding the opposite to get 0. Okay, don't get that confused with the multiplicative property of 0. And basically all we're saying there is any number times 0 equals 0. So I can say b times 0 equals 0. Or I can say 4 times 0 equals 0. If you would please, what I'd like you to do is to write down the day of the week it is right underneath where you see connections. What day of the week is it? And if you would also please, if you have any questions, please write them down at the bottom of the page. Thank you.